Hello, good day, my fans out there. I remain your chemistry lecturer on social media. My name is Dr. D.I. June. Our last lecture, we discussed about Charles' law, and we said it is stated that the volume of a fixed amount of gas is directly proportional to the temperature, provided the pressure remains constant. So, we give a mathematical equation, V1 over T1 equals to V2 over T2. Once you can get that equation, you have defined Charles' law. But right away, I want to discuss the topic titled The Absolute Zero. The Absolute Zero, which is also called the Kelvin. Now listen carefully to what I'm going to say as I go through step by step from what I have in my notes. Charles, as a scientist in his time, discovered or found out that the volume of a fixed mass of gas will either increase or decrease by 1 over 273 of its volume at 0 degrees Celsius for every 1 degree rise or fall in temperature, provided the pressure remains constant. Look at it here. 1 all over 273. It is saying that if the volume of a gas, though we don't know the volume now for now, but assume you have a volume of a gas, you now share this volume of gas into 273 portions at 0 degree Celsius. Now, Charles is now saying that if you increase the temperature from 0 degrees Celsius to 1 degree Celsius, it means one portion of that 273 will be added to the 273. That's what he's saying. And that if from that 0 degrees Celsius, you will reduce the temperature to minus 1 degree Celsius, it means 1 over 273 of the volume will also decrease. That's what he's telling you. So that is why it's nobody at the board here. You may not get it clearly because it is worked mathematically, but ordinarily you can see it here. At 1 degree Celsius, from 0 to 1 degree Celsius, 273 plus 1 over 273 times 273 dm3, that's the volume. If you want this work mathematically, from here to here, just give you 1. And 1 plus 273 is 274. Now, on the other side, if the temperature now decreases by 1, minus 1 degree Celsius, it will now be 273 minus 1 over 273 times 273. If you work it out, here is just 1. So 273 minus 1 is 272 dm cube. Now, according to the above expression, when a gas is cooled, 0 is the 0 temperature. Anything below 0 is minus 1, minus 2, minus 3 to infinity. So when a temperature of a gas is cooled to minus 23 degrees Celsius, it means its volume will be 0. That's what it's telling you. So, in other words, minus 23 degrees Celsius is the lowest temperature so far attainable, and it is called the absolute zero. If you have a graph like this, this is the y-axis, x-axis. This is the 0 point, certain point. Here it goes up. Here is going this way. This is increasing. The moment it goes this way, here is now minus 1, minus 2. So the moment a temperature is cooled from this 0 this way to minus 273. It means the volume of the gas is no more in existence. That's what we call the absolute zero. Note, the Kelvin temperature is also called the absolute zero, has minus 23 degrees Celsius as its starting point. We have degree Celsius, we have degree Kelvin. So in Kelvin, minus 23 degrees Celsius is its starting point. So it is now called the absolute temperature scale. Hence, 0 degrees Celsius will be equal to 27 degrees Kelvin. That means that when Kelvin is now minus 23 degrees, the temperature will be 0. Now, in Sachs law, before you start calculating, because of this issue that is here about this absolute degree or absolute zero, you will convert degrees Celsius to degrees absolute before you start solving the problem. So to convert a Celsius temperature, which is now degrees Celsius, to a Kelvin temperature K, the K will not count what? The degree in Celsius plus 273. When you have done that, it becomes the absolute temperature. So without doing that, you won't be able to solve any problem concerning Sachs law. So this is what Sachs discovered, the absolute zero. And therefore, any person calculating problem in Sachs law must take this into cognizance, that the degrees provided in the problem in Celsius must be converted to degrees absolute by adding 273 to it. And the answer will be in Kelvin. So likewise, if you want to convert from Kelvin to degrees Celsius, the answer you have, you subtract 273 from it, and the answer will be in degrees Celsius. Please like it, comment, and share this video. Remember to always subscribe to my YouTube channel. Thank you.